Hello, this video is going to show how we can achieve functional safety using Infineon's AURIX Development Studio. Connected to my laptop at the moment, I have this evaluation board. It's an Infineon Tricore device. It's a TC375. Now, the starting point is AURIX Development Studio. And inside here, I've created this simple cash register project. And as we can see, there are three mains here for CPU 0, CPU 1 and CPU 2. For CPU 2 and CPU 1, basically I've just left those as a while 1, and it's the CPU 0 which I've added some code inside here. So I'm initializing a UART, and then I'm executing in this infinite loop, basically reading characters from the UART and then passing them and processing them. So first of all, let's check we can build this application. So let's go and do a build. This is now going to use the tasking compiler in order to be able to build the ELF file. So just wait for that to complete, and now we have an ELF. So let's go and execute this on the target. So I'm going to start here by opening the debug configurations, and I'm now going to connect to the board, going to download and flash onto the target, and then it's going to execute. Now I've got a teraterm that's listening to the serial port, so we should be able to control the execution via this terminal. Well, let's start the execution. So that's now running, all three cores are running, and let's now go into the teraterm, and I can type in various commands like S for start, 1, 2, 3, 4, 5, B, a barcode, E for end, and it prints something out. I can try random characters like this, and I can effectively exercise the code. Now, as the code exercises, I'd like to find out, well, how much of that code have we actually exercised? Well, let's find out. So first of all, let's just go back here. Right, and now I'm going to open up TBvision. Inside TBvision, I've already analyzed the code, and I now want to be able to instrument this code and execute it on the target and find out, as it executes, how much of the code have we actually exercised. So I'm simply going to perform the build. I've already generated the instrument program, and the build is simply going to switch the instrumented code, or switch the original code with the instrumented code, and that now allows me to go and perform the build inside of here. So if I scroll down a little bit, we're going to be able to see the code. So let's go down, and there we've got the while 1 loop. And inside here we can see we have first of all a number of probes. So when this probe is hit, we'll know we've executed this particular line of code. Well, what I've done is, since this is an infinite loop, or while 1, I need some way of being able to say, well, that's enough, stop, let's get the data off the target. And so I've added into the instrumented code this little bit of code here to say that, well, if I enter the character hash, then I want to stop the execution and basically upload the results. So let's check, first of all, we can do the build. So I'm going to do a clean, and now I'm going to do the build. So once again, this is going to use the tasking compiler in order to be able to build the application, and we're going to end up with another ELF file. So let's go and debug this just as we did before. So once again, I'm going to perform the debug, and in order to control it, once again, I'm going to start my teraterm. Okay, so wait for that to download the target, and now we can start the execution. And if I go back to teraterm, we should be able to do the same as we did before. S, 1, 2, 3, 4, 5, B, E for end, and do R for random. And there we can see we've exercised the code. So now I'm going to press the hash key, and when I do so, that then has uploaded the results. So let's stop the execution, and let's go back now and put the source code back as it was. And now we're going to be able to perform the dynamic analysis. So we should be able to see here that it's found the results. We can now analyze these, and we're going to be able to find out, well, how much of that code have we actually exercised. So just wait for this to finish analyzing the file that it uploaded, and now we're going to be able to take a look and see, well, how much of that code did we exercise. Well, let's take a look at a test manager report, and this shows everything we've done so far. So we've done a code review and a quality review. We could look at those if we wanted, but what I'm interested in here is the dynamic report. I want to see, well, what statement coverage, what branch coverage, and even MCDC have we obtained? Well, we can see for the CPU 0 main, we've got 100% statement, 100% branch coverage. What about for cache register.c? Well, we've got 99% statement coverage. Let's go into the cache register. We can see we've had one run, and as we scroll down, we can see, well, we haven't got full coverage for add product. If we take a look at add product, we can see we've never executed this line of code here because we've never added 50 products. So what I could do if I wanted is to execute this another time, enter 50 products, and then we'll be able to execute these lines of code here. Okay, so hopefully that's given you a quick overview of how we can perform functional safety with Infineon's AURIX Development Studio. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.